Okay, hey there, it's Miss Cronin here. This is continuation of lesson 2.5 and 2.9. We're following along with your textbook. In this video, what I'm going to show you how to do is I'm going to show you how to simplify I to a raised to an exponent higher than 2. And I'm also going to show you how to graph complex numbers and then find the absolute value of a complex number. Okay, so let's start here. This is part 3 of the videos associated with complex numbers. So if you've seen the other videos, hopefully you know that I is the square root of -1, and we just call it I. And so when you square the square root of -1, I don't want to write that there. When I square this, I get the square root cancels out the square, and I'm left with just -1. So I squared is -1. And then let's think about what I to the third power looks like. I to the third power, I can break that into I squared times another I, and then I squared we just discovered is -1, and then times I. So I to the third power is the same thing as -I in simplified form. And I to the fourth, if we look at what that is, we can take I to the fourth and split it into I squared times I squared, because it works just like with your rules for exponents. You would add those exponents together, so I to the second times another I to the second. If you add those exponents, it's I to the fourth. So these two things are equivalent. And then think about what I to the second is. It's -1. And then I have times another -1. A -1 times a -1 is a +1. So I to the fourth brings us back to 1. Okay, now think about what I to the fifth would be. For I to the fifth, we can split that into I to the fourth times another I. Alright, so we have I to the fifth, and I didn't write down I to the fifth here. I to the fifth you can split into I to the fourth times another I. And the reason I'm using I to the fourth instead of, like, I could do I squared times I to the third and work with that, but I to the fourth is going to make things easy, because what was I to the fourth? I to the fourth was 1. So this I to the fifth is 1 times I. So we're back now to where we started with I. And this pattern is going to, you'll see there's going to be a pattern here. If I find I to the sixth, I can split that into I to the fourth, and I'm going to want to try to think of like how I can rewrite it in terms of I to the fourth, because I to the fourth is 1. So I to the fourth times I to the second is equivalent to I to the sixth, and then I to the fourth is 1, and I to the second is -1. So multiplying those two things together, I to the sixth is going to be -1. So keep going here. I to the seventh, if I figure out what I to the seventh is, I'm going to write I to the fourth times I to the third. So I to the fourth, remember, is 1, and I to the third was back here, it's -I. So 1 times -I is -I. And I to the eighth, I'm going to move over here. I to the eighth you could write as I to the fourth times another I to the fourth. And that's 1 times 1, so I to the eighth is 1. So if you look for this pattern, we have back at the top here, I gotta scroll. So we have I, -1, -I, 1. I, -1, -I, 1. That pattern would continue on, because if I want to find I to the ninth, I can write that as I to the eighth, or another way to think of it is I to the fourth squared, but I to the eighth, and then there's another I. So I to the eighth is 1, and 1 times I would just be I. And I to the 10th is going to end up being, you're going to have a -1, because if you look at I to the 10th, we can make that I to the, well, here's another way to break it up. I to the fourth times I to the fourth times I to the second, because you'd add your exponents. 4 plus 4 is 8, plus 2 is 10. So these expressions are equivalent. And I to the fourth, this is 1 times -1 1. So you have I to the 10th is negative 1. And you'll see the pattern is going to go, we start with I, and then it's negative 1, negative I, 1. I, negative 1, negative I, 1. I, so I to the 9th would be I to the 10th is going to be negative 1, I to the 11th will be negative I, and then I to the 12th is going to be back to 1 again. So there's a couple shortcuts to doing this. I gotta get myself out of the way. Okay, I to the 20th. So what you want to do, keep in mind that you could use I to the 8th or I to the 4th because they're both equal to 1, but it's easier to remember just one of those things. So let's remember that I to the 4th is 1. So when you're trying to figure out what I to the 20th is, you need to know your rules for exponents, but I to the 20th can be written as I to the 4th power to the 5th power, because the rule for exponents is you would multiply those exponents together, so I to the 4th to the 5th power is equivalent to I to the 20th. So I to the 4th is 1, 1 to the 5th is still 1. So basically what you're looking at is you're looking at the exponent, and if you divide the exponent by 4, the remainder, if it goes in evenly, there's no remainder and you'll get 1. If there's a remainder, then look at what the remainder is. Like, let's look at 15 here. We could write this as I to the 4th to the 5th, that's the 20th. And how many i's do we still have? That's this expression right here is I to the 20th, so we have to multiply by I to the 3rd to get I to the 23rd. And this whole piece will be 1, and you have I to the 3rd, which is equal to negative I. And I to the 201st power. So think about how many times does 20 go in evenly to 201, and what is the remainder? So let's look at that. So if I take 201 and I divide by 4, I'm just going old school here. 4 times 5, that's 20, and that's 0. So bring down the 1, and we're going to have a remainder of 1. So it goes in, I did something wrong, didn't I? No? But, okay, wait, yes I did. All right, if you take and you divide 201. Okay, it wasn't wrong, I just wrote it wrong. Okay, so we have, 4 goes into 1, it would be 0 times, and you'd have 0, and now we'd have our remainder of 1. So 4 times 50 is 200, but then to get this answer, to do 201 divided by 4, it's the same thing as, you can write it as 4 times 50 plus a remainder of 1. And so when you have a remainder of 1, that is going to be equivalent. So if the remainder after you divide by 4, if the remainder equals 1, then it simplifies to I to the 1st, which is just I. If the remainder is 2, when dividing the exponent by 4, then, and I'm going to use that implies, it is equivalent to I squared, which is negative 1. If the remainder is 3, then it's going to be the same thing as I to the 3rd power, which was negative I. And if you had no remainder, so let me go back up here. Well, if the remainder is 0, because those are the only possible remainders you can have when you're dividing by 4. It's either a remainder of 1, 2, 3, or no remainder. What that means is that it's I to the 4th, which is 1. All right, so going back here, this is the shortcut. So when you divided 200 and 1 by 4, our remainder was 1, so this is equivalent to I. So think about 56. If you divide 56 by 4, you guys go ahead and do it. So 56 is divisible by 4 evenly, so there's no remainder. So this is equivalent to 1. And why don't you do 18 and 19, and then come back and check your answers. So for 18, there's no remainder, so it is also 1. And for 303, well, 300 is divisible by 4. And so you're going to have a remainder of 3, so this is equivalent to I to the third, which simplifies to negative I. Okay, so graphing. Let's look at how you graph complex numbers. And this is actually, this part, actually I think you'll find to be pretty relatively easy. So with this, we're going to have what's called a real axis, and we're going to have an imaginary axis. So it's just like graphing an ordered pair. So when you're graphing -3 plus 0i, the -3 is going to go on the real, you're going to go -3 in the negative real axis, and then you're going to go 0 in the imaginary axis. So we're going to go right here, -3, comma 0 on the imaginary axis, and this would be point A. So if you look at B here, we have, let me do a different color, we have -2i. So what's the real part? The real part would be 0, and so you're not going to move left or right on the real axis, but you're going to go down -2 on the imaginary axis, because the imaginary part is -2i. Graphing C, we have the real part is 4, so you're going to go over 4 in 1, 2, 3, 4, and you're going to go up to 3i on the imaginary axis. So this would be my C. And then last but not least, let's do D. You guys graph D and then check it. So you're going to go -5 and then -1, so your point for graphing -5i is equal to D. Now, I was going to try to fit in absolute value of a complex number in this video, but I'm not going to be able to do that. I'm going to run out of time. This only allows me 15 minutes, and we're almost there. Let me just tell you what it is, and then I'll show you how in the next video. When you're finding the absolute value of a complex number, you're going to be finding the distance from the origin to that to where it lands on the imaginary axis or the complex number graph system. Okay, so there will be one more video coming up.